Okay, so we're going to make a fairly quick video looking at the difference between speed and velocity. So you may have picked up from the previous videos on the two concepts that one key difference is that speed is a scalar quantity and that velocity is a vector quantity. But what we're going to do is start off by exploring what that means and then look at its significance in terms of doing calculations with speed and velocity to see what impact it has. So the first thing I'd like you to do is grab yourself a rough piece of paper and have a go at answering each of these 4 questions. And you can see we've got some information in brackets to help prompt you for the keywords that I'm looking for in your responses to those questions. Okay, so I'm going to assume you've had a crack at answering these questions. If you haven't, do pause the video and have a go. So a scalar is a quantity that can be described using only one number, which we call the magnitude. A vector requires 2 numbers to describe it. It needs a magnitude and a direction. There. So in terms of the scalar and the vector that we're going to be looking at specifically, so we're going to be looking at speed, which is a scalar. So then, well, what is speed? Well, speed is actually an abbreviation for instantaneous speed. Speed is the rate of change of distance or the gradient of a distance versus time graph. And then we're going to have something very similar for velocity. Let's clear that off the screen so we're not overcomplicating things. So again, velocity is an abbreviation for instantaneous velocity, is the rate of change of displacement, or the gradient, displacement versus time graph. Okay, so here you can see the key difference between the two. They look really similar. One is determined from distance and one is determined from displacement. That's the only real difference between the two, or at least, so that's what leads to the different ways that they behave. So both kinds of speed, so average speed and instantaneous speed, are determined from distance, either from distance versus distance divided by time, or the gradient of a distance versus time graph. And so because distance is a scalar, that means that speed is a scalar quantity, because time is also a scalar quantity. So for example, if we were quoting a speed, what we would say is speed is 2.3 meters per second, for example. There, we only need a magnitude. Velocity is determined from displacement. Now, displacement is a vector quantity, so velocity, therefore, is also a vector quantity, which means it has magnitude and direction. So for a velocity, we would have to say, I don't know, 5.4 meters per second north, or 2.3 meters per second left, or give some sort of angle that it's traveling at, something to indicate its direction. But in terms of something they have in common, they're both measured in meters per second. So let's have a look at some a difference of the way they behave mathematically. So we've seen this already with distance and displacement. So you're going to see very similar ideas here with speed and velocity. So if object has a speed of 5 meters per second and it's changed by 2 meters per second, what is its speed now? Well, the speed could be 5 plus 2, giving us 7 meters per second, or it could be speed is 5 minus 2, giving us 3 meters per second. So because we're not told how it changed, it could be either of the two, but we know it'll be one of those two there. So scalar maths is really simple. We're just adding or subtracting the change. If an object has a velocity now of 5 meters per second to the right, and it's changed by 2 meters per second, what is its velocity now? Now you'll notice, or the key thing to spot is here, is this has not been given a direction. So what this could look like. So let's say we have an object which is going at 5 meters per second that way, and it could be that we add on to that, so our change in velocity that way. So therefore our velocity is going to be 5 plus 2 is 7 meters per second right. We could also have the object going that way, but the change is going that way. So we could have velocity is 5 minus 2, giving us 3 meters per second, again, right. But we could also have the velocity going that way and our change in velocity going this way. So our final velocity would actually be the square root of 5 squared plus 2 squared, giving us a square root of 29, which I have got no idea what that is. Somewhere between 5 and 6, 5.44 meters per second, and we'd need to do some trigonometry to work out his, so sort of downwards to the right. The change could also have been upwards, so it could be 5.4 meters upwards to the right. We could also have it at any other angle. So we can't actually specify what the velocity is afterwards because we don't know the direction of the change. And depending on what that direction of the change is, that will change what the final velocity is. Whereas here, with speed, it didn't matter what the direction of the change was. We knew it could either be increasing or decreasing the speed, but that's it. Whereas here we actually have, and in theory, an infinite number of velocities we can produce at the end because the change could be in an infinite number of different directions. Okay, so let's finish off. So we got a bit bogged down in the calculations there, but the key thing I want you to take away here is what the similarities and differences are between speeds and velocities. So on your rough piece of paper, write down what things do they have which are the same and what things do they have that make them different. Okay, so in terms of what I would come up with there, so one time I might start with differences, but I tend to go with similarities first. Both are measured in meters per second. That we key. So in terms of, that's the only one I think I can think of. Differences, velocity has a direction, whereas speed only has magnitude. I probably should add magnitude and direction. This means they also behave differently when doing change calculations. And that's a really important difference that we often kind of miss or don't appreciate when we're dealing with scalars and vectors. Most people can tell you this, but actually describing how they behave different mathematically is what is the important difference between scalar and vector quantities. Okay, so that brings us to an end on this speed versus velocity video. And then in my next video, I'll pick up on what acceleration is.